Now, I'm from Group 7, and today I will represent the Spectre Attack Lab. The Spectre Attack is one of the race conditions vulnerable through the speculative execution and the branch prediction attack to many CPUs like Intel, AMD, ARM. Its impact is read the content of memory in other user running programs. It is reported by two groups of people. It's Chen Hong and the Paul Culture. This is the logo of the Spectre Attack Lab. What is the Spectre Attack for? When it attack, it will attack to the security information, especially is your password, your credit card, your social number. I want to introduce to you about the three pubs riddle. This is an old riddle, but it plays an important role to the concept of this attack. Three identical line features, each contain an identical line pub and line clock. Each line is connected to one of three switches inside the room. Each pub is switched off at the present. You are outside of the room and you came in. The door is closed. Before opening the door, you may play around with the slide switch as many times as you like. But once you open the door, you may no longer touch the switch. After this, you go outside and examine the light. How can you tell which light goes to which light? And to make this riddle harder, I adding the security guy into this room, and I also have the secret number in the first, second, and third switches. There is one of three switches have a secret number, and your job is go into the room and get the secret out. But when you enter the room, you must have access rights. The security guy, he will check your access rights but he want to optimize your time. So when he's checking the access rights, you can do anything you want to the one of three switches. But if you don't have access rights, he will kick you out, cleanse your memories, and turn off the lights. So how can you solve this problem? And the answers is when you go in, you will turn on the lights, have the secret number. And if you don't have access right, he will kick you out and cleanse your memory. But there is a trick that one of the lights you turn on is warm, so you can get the secret number through the warm lights. So it is called this side channel. So that is the solution that you can get the secret out of the room. but you don't have to remember anything you do. According to this concept, they call the concept is a side channel attack that it will extract the classifies information, the secret information from the system through another logic parameters. It is the physical parameters analysis. It is the warmth of the light. Is it timing information or is it a sound? Especially is you remember they uh, used to be this in the past they using this phone, and when you want to call you have to play it around, and each time you roll it is it create a spectral sound, a spectral sound. So you can hear it and know that which number they are calling. How we use the light bulb triddle concepts into the attack. As you can see, there is 2056 switches, 2056 block have around like 2056 switches, and when I turn on the switches 94, it will pushes into the CPU cache. Now it's placed around like a pub, as this pub is become hot and another pub is cold because I don't access into this block and this block, so it will be cold. So when I have a loop, attack to one by one block, which have a fastest rate. So it is the secret number. And now I will introduce to you how to use catch at a side channel. At first, you will flush the side channel, and you fill it with one, and then you flush the value of the array of catch. And at the second function, you will access to the secret block. As you can see in the victim function, you not return any secret number, but you access to the secret block. In the reload side channel, you will look to 256 blocks as I present in the last slide, and when before you touch one of this address, one of this, you will start the time one, and after you access to the address, you will have a time two is the time right now minus the time one, so you have the time to touch this address. And if the time to touch one of this, which is lowest or smaller than the catch and hit threshold, so it will be the secret number. And now I will introduce to you the secret room and the security guard in the Spectre Attack. Is in the Spectre Attack, you working with the software protection. That means this is the address that you have the access rights on the programs. But when you want to access to this block of memories, you will get into the access protection function. If it's smaller than the security, the protection values is smaller than a protection value, you can get the buffer at the position X, and if it's not allowed, you will return 0. It will return 0 to you. And so, how can we attack on the memory and pass through the access protection? Get the secret number from a restricted region. Now I will represent to you the out of order execution. This is different from the light path problem I talked before. This is if you want to go inside of one room, the security guy will let you come in, and check your access rights. When he check the access rights, you can do anything you want. Then, if you have the access right, you will allow to continue the instruction. But you don't have an access right, he will kick you out of this function, out of this room, and cleans all the memories. But it is different from what I'm saying, that in this situation, the CPUs will guess which way you guess that he will let you come in or kick you out before checking your access rights. And in this situation, the CPUs gonna guess what branch you may go by the history. If your history is access to the right blocks of memories, like 9820, this will let you come in a room and do whatever you want while he's checking your access rights. So the attacker will use this vulnerability and fake the history. He will access a memory many times, and history is he's go to the he will go to the right branch, so he can steal the secret number, like in the light bulb problems.
Hi everybody, now I'm start my demo on our Spectre Attack lab. Yeah, there are 6 tasks in this lab. For task 1, we compare time to access cache and memory. Okay, we can see the 3 and 7 are in our cache. So the time to access 3 and 7 are much smaller than the other. Let's see, okay. So we can use the time difference to exploit the CPU. For task 2, we use the time difference to get a secret value. We use the flush and reload methods. Let's see. So first we flood the side channel, that means we clear our cache. The second, we call the victim function, we inject the secret value that we want and put it in the cache. So we reload the side channel to get the value. Reload the side channel, that's basically find the element that had the smallest time access. So that is will be our secret value. Let's see. Our secret is 94. Yeah, we get it, 94. That easily, right? Easy. For task 3, we use this cat time to overcome the out of the execution. Okay. First, we flood the side channel, that means we clear our cache. Then we train our CPU to take to the truth range, that means we inject to the victim function with small value. So that's the CPU will predict the next execution will be true. Then we inject a big value, 97. Normally this value would be 4, but due to out of the other execution, 97 will be on the cache, and then we reload the side channel to get it. Yeah, we get it 97 so easily. So task 4, instead of sending the value 97, we sending the first character of a string. So that basically the same. So I expect to get the value m. Yeah, m here. Why 0 here? Oh, what 0 here? Because the element 0, array 0, may be adjacent to some variable in a code. So it's accidentally appear here, so we just ignore it. Yeah, got it. The letter M, my secret. Next we use an improve method on this because this method is so unstable. So we make an improve that we attack this multiple time, and then we find the element that appear most of the time. So that will be our secret value. So our secret here, try here, so I expect the value to be h. Right. So one note here that we don't want the value 0, so we start with from 1, because 0 might maybe always appear, so we don't want the element 0. So we attack and we get the value h. Yeah, so far so good. So final task, the most interesting one, we use Spectre Attack to get a secret string, for example a Wi-Fi passwords. So here my Wi-Fi passwords, it không có pass. Yeah, we run the Spectre complete and get it. Oh, I failed this time. Yeah, I got it now. Basically this Spectre complete is just multiple time doing incrementally doing the spectral attack. to get it the character. Yeah. Okay, we know that the Spectre Attack is very dangerous. And how can we prevent us? Unfortunately, the flaw is in the hardware, so it's very difficult to fundamentally fix this problem unless we completely design a new hardware, so that problem won't go anywhere soon. And also Spectre fixing also make your computer slower. This is sad. The bad thing we can do is just get updated regularly. Don't avoid this update on software and hardware. Don't avoid it. So at the end of our seminar, in this seminar we discovered that what is Spectre Attack, what it used for, and how the Spectre Attack works. We also demo a Spectre Attack, and we see how to prevent the Spectre Attack. That's all for our presentation. Thank you for listening.